Okay, so in the earlier lecture I talked about the Hamiltonian formulation. Now I will discuss in this lecture Poisson bracket. This is also a very interesting concept. So for this, let G is a dynamical variable, and this is depending upon Qi, Pi and T, and this is a dynamical variable and it is represented by canonical conjugate variables. Canonical conjugate variables, say Q, R and P R. These are the canonical pair of conjugates, right? So if I take time derivative of this dynamical variable, that is dg upon dt, then it can be written as summation over R curly G over curly QR and QR dot plus curly G over curly PR and PR dot, right, plus curly G over curly T, right? So this is one thing which we have to keep in mind. And if I recall Hamilton's equations of motion, let me recall Hamilton's equations of motion. Canonical equations of motion. Then according to those equations, that this QR dot, it is equal to curly H over curly PR and PR dot is equal to minus curly H over curly QR. These we have to keep in mind. And if I use their values here in this equation, then this will be equal to that dg upon dt must be equal to, let us put it here, curly G over curly T plus summation over R and curly G over curly QR into curly H over curly PR minus curly G over curly PR and curly H over curly QR, right? So this equation can be written like this. Now here this term can be known as Poisson bracket of the dynamical variable. So this is known as Poisson bracket of dynamical variable, and this dynamical variable is depending upon these canonical conjugate variables. So right, so thus I can define Poisson bracket like this. This is a way to define a Poisson bracket of G with H. Sorry, it is Poisson bracket, so let me write down it like this. So it is equal to curly G over curly QR, curly H over curly PR minus curly G over curly PR and curly H over curly QR. So this is the Poisson bracket. This is a way to define it. This is the Poisson bracket, right? So we have to keep this in mind. So let me generalize this idea. So to generalize, consider two dynamical variables. So let A and B are two dynamical variables. Then Poisson bracket for for these dynamical variables is defined as that AB, its Poisson bracket is equal to curly A over curly QR, curly H over curly B over curly PR minus curly A over curly PR and curly B over curly QR and summation over R. So this is a way to define it in this way, right? So let me write down this equation number 1 and this is equation number 2. Right. Now I will discuss some properties of Poisson bracket. So let me discuss certain important properties of Poisson bracket. Properties of Poisson bracket. Right, let me discuss these properties. So let us discuss first property. So first property is that I will write down these properties and then try to prove those properties. So it is, let me talk about first property. First property is AB, its Poisson bracket is equal to minus BA, means order can be changed. Let us try to prove it. So consider AB Poisson bracket, and this can be written as curly A over curly QR and curly B over curly PR minus curly A over curly PR and curly B over curly QR, right, and its summation over R. If I take negative sign outside, then it can be written as summation over R curly A over curly PR curly B over curly QR minus curly A over curly QR and curly B over curly PR. Means if I take negative, this goes that way and this towards this side, because negative can be taken outside. Now I can write down this here and this here. This is simply the product. So if I do in this way, then it is minus curly B over curly QR curly A over curly PR minus curly B over curly PR and curly A over curly QR. This is because of commutative nature of product. So what is it? It is Poisson bracket of BA right. So that means this is equal to this one, hence we have proved this, the first property. Now let me discuss second property. So for second property, let us proceed as follows. So let me write down second property, and this second property is this is the second property, and it must be equal to, it is CAB. Here the C which I have taken, it is a constant, right? So let us try to prove it. So for this, again consider left hand side. So if we consider left hand side, then I can write down it as so need not to write down the left hand side, but simply I will write down that CAB, where C is a constant and multiplied with one dynamical variable A. So it is curly CA upon curly QR curly B over curly PR minus curly CA upon curly PR and curly B over curly QR, and it's a summation over R. So here C is a constant, here C is also a constant, so it can be taken outside the differential. So if I take it outside, then it can be written as like this. So it is C curly A over curly QR curly B over curly PR minus C can again be taken outside, so curly A upon curly PR and curly B over curly QR. So if I do like this, and here this is C and this is C, so it's common, so it can be taken outside, so it is C can be taken outside the summation. So I can write down it as curly A over curly QR curly B over curly PR minus curly A over curly PR and curly B over curly QR. So I can write down it in this way. So it is basically C and it is a Poisson bracket of A and B. So it is A, B, right, like this, right? So hence we have proved the second property. Now let me go to the next property. The third property which I am going to discuss with you. Say sum of two dynamical variable and its Poisson bracket with another variable C, dynamical variable, then this can be written as Poisson bracket of AC plus Poisson bracket of BC. So now again consider the Poisson bracket of A plus B comma C. So it is equal to curly A plus B over curly QR curly B curly C over yeah, curly C upon curly PR plus it is curly A plus B over curly PR and curly C over curly QR. That's what I am considering, and summation over R. So it can be written as curly A over curly QR, it is plus curly B over curly QR curly C over curly PR plus curly A over curly PR plus curly B over curly it's PR again, right? Yeah, curly PR and curly C over curly QR and whole summation over R. So it's equal to now now I can write down it as summation over R. It is curly A over curly QR curly C over curly PR, this multiplied with it, and plus curly B, oh sorry, I've did some mistake here, let me correct that. Yeah, negative will be there. This is negative, this is negative, and let me go to the earlier also. Yeah, I have taken negative here. Oh yeah, it's fine. Yeah, everything will be fine, but here I have mistaken. So now it is curly B over curly QR and curly C over curly PR minus curly A over curly PR curly C over curly QR plus curly B over curly PR and curly C over curly QR, and it should be written like this, right? So if I open this summation, then this can be written as summation over R. Let me put these two together and these two together. Then now let me proceed as follows. So it is equal to summation over R curly A over curly QR curly C over curly PR minus curly A over curly PR and curly C over curly QR. This is one part, and then plus summation over R and curly B over curly QR and curly C over curly PR minus curly B over curly PR and curly C over curly QR. This we can write down, right? So what is it? This is the Poisson bracket of AC and this is the Poisson bracket of BC, right? So hence we have proved this property. Then fourth property which I am going to discuss with you. So it is A dot A, it is always equal to 0. Means Poisson bracket of some dynamical variable with itself is a 0. So for this, let us consider, as we know that from first property, that Poisson bracket of AB is equal to minus BA, and as I know that here A is equal to B, if I put their values, then this equation will become AA, its Poisson bracket is equal to minus AA. Bring this towards this side, so it is twice of A comma A. Poisson bracket, this is equal to 0, and this leads to the Poisson bracket of A with itself is always a 0, right? Then let us discuss another property. So it is, if C is a constant, then bracket of C with any dynamic variable x is 0, that is Cx, its Poisson bracket will be 0, where C is a constant. So let me try to prove it. So it is a Poisson bracket, and it can be written as curly C over curly QR and curly X over curly PR minus curly C over curly QR and sorry, not QR, but it's PR, and curly X over curly it is QR. As I know that this C is a constant and its derivative will always be 0. Its derivative will always be 0. So this makes this whole thing will be equal to 0, right? So thus we can prove that this is equal to 0. Now let us do one thing. Let us go for the next property. It's again very interesting. So if AB C, its Poisson bracket is equal to, it is AC B plus ABC, right? So these are the Poisson brackets. So it's again very interesting property. So let us try to prove it. So for this, let us consider it is curly A B over curly QR curly C over curly PR minus curly A B over curly PR and curly C over curly QR, and it's a summation over R, and this is equal to let me apply product rule here. So if I apply product rule here, then this can be written as it is curly A over curly QR into B and curly C over curly PR, right, plus first function as it is curly B over curly QR and curly C over curly PR, right. Here I have solved this part, and this can be written like this, minus curly A over curly PR into B curly C over curly QR plus curly into it is A curly A B over curly PR into curly C over curly QR. Let me write down it in this way, right, and let us put these together, right, this with this. So if I do this, then and bringing this towards that side, it can be taken outside, right, and here they are already outside. So that means what I can do, that it is R, it is curly A over curly QR curly C over curly PR minus curly A over curly PR curly C over curly QR, and outside it is B plus A curly B over curly QR and curly C over curly PR minus curly B over curly PR and curly C over curly QR and let me bring this summation. Okay, so this can be written as, this is summation over R curly A over curly QR curly C over curly PR minus curly A over curly PR curly C over curly QR, and here B is outside, then again summation over R, and A is just outside this A, so it is curly B over curly QR curly C over curly PR minus curly B over curly PR and curly C over curly QR. This we have to take, right. So it is Poisson bracket of AC, and this B is multiplied here, plus A and Poisson bracket of B C. So hence we have proved this result. Then again, very interesting, very important fundamental Poisson brackets now I am going to discuss. After that, it's a fundamental Poisson brackets which I am going to discuss, and they are very important, right? So the result is that if we are having Qi, Qj, its Poisson bracket is equal to, it is Pi, Pj, and it is always 0, and then this is Qi, Pj, here Poisson bracket is equal to delta Ij. So these are known as fundamental Poisson brackets. So let me first of all talk about it, and then this, and finally I will talk about this. So let us consider Qi, Qj, its Poisson bracket, and it can be written as curly Qi over curly Qr and curly P, curly Qi and curly Qj over curly Pr minus curly Qi over curly Pr and curly Qj over curly Qr and summation over R. And as I know that this Qj and P with respect to Pr, Qj is a constant, so that means its differential will be 0, and similarly its differential will also be 0, keeping in mind that curly Q over curly P is always 0. So that means if these two will be equal to 0, so this makes this whole quantity equal to 0. Then let me talk about this next part, so this one. Similarly, Pi, Pj, that's Poisson bracket can be written as curly Pi over curly Qr and curly Pj over curly Pr minus curly Pi over curly Pr, and it is curly Pj over curly Qr, and this is equal to 0, and this is also equal to 0. So that means this makes this equal to 0. Let me try to talk about now this part. So let us proceed as follows. So it is Qi, Pj, its Poisson bracket, it can be written as summation over R and curly Qi, curly Qr, curly Pj, curly Pr minus curly Qi, curly Pr and curly Pj and curly Pj, and it is P, sorry, it is Qr, right? Now this is equal to 0, and this is also equal to 0, because it is Qi and it Pr, it is Pj and it is Qr, so that's why the differential will be equal to 0. So that means this is simply equal to summation over R, curly Qi over curly Qr, curly Pj over curly Pr, so IR. So that means this can be written in the form of a delta function. So it is summation over R, it is delta IR, this part is delta IR, and it is delta JR, and this can be simply written as delta Ij. So hence we have proved this, that is equal to this one. So now we have in this lecture discussed some very important what do we call important properties of Poisson brackets, and fundamental Poisson brackets we have also discussed, and these three fundamental Poisson brackets are used in later on, right, in so many problems, right? So that's all for this today's lecture.